All right, welcome to the next video in our series. We are talking about inheritance and the act of using multiple classes to support your program. What we want to talk about right now is how do we resolve encapsulation and inheritance? What does it mean to have private variables and then have those private variables passed down? What do we get access to, we don't get access to? And then how can we use the super keyword? Super has many uses. In this video, we're just going to be talking about when a subclass wants to get access to a parent's methods. How would we do that? So let's begin by talking about what it would mean to encapsulate one of these classes, some of their fields. How will we get access? For the purpose of this activity, I'm going to give animals a second quality. I'm going to give them an int age. I'm aware that double might be a better variable for this, but for the sake of simplicity, I'm going with an int age. And recall, as soon as I change this in animal and I save the animal class, dogs would then also get access to this age field. Well, there's going to be a previous video about encapsulation, what it means, but here's a quick refresher. Encapsulation means that we are probably concerned that just directly accessing some of the fields of our classes could be harmful. An example of this would be if I said dog D equals new dog, and I went ahead and said d.age is equal to negative 300. Well, I don't know any dog whose age is negative 300. I'm not even sure what that would try to represent. That's clearly a mistake. And if I want to properly build, properly have this field age, I should probably protect it a little bit. And the way to do that is by making it private. And what that means is that the only way to access it is through a public setter and getter. Now, when I do this, you're going to notice something change here. And it says the field animal.age is not visible because we have changed the access to it. Now, what's funny is within the method of the animal class is I really could change age. I could be like, every time you eat, your age increases by 1. This is acceptable because private fields can be changed from within their class. The problem is that any other class, which includes inheriting classes, so even though a dog is an animal, even though the dog gets everything from its parent, as soon as we are outside of the class where it is declared private, we don't have access. So we're going to want to make setters and getters, which as a refresher are methods that either acquire a value for us or change a value. So for example, it could be public, let's make the getter first. Public int age, we would call it public int get age. And we would just return age. And the reason that this works is because we are within the class where it's private. So we have access here to the age field. And what's nice is if I needed to get age down here, I could say d.get age. I can't perform an assignment anymore. But at least I have access to this because it's public. The real purpose for having this would be, let's go ahead and make the public setter. Public void set age. Recall that the return type for getters is got to match whatever the type it is that you're returning. You're going to get that, so you need to return something of that type. Setters, we're just sending information down, so we don't need a return type, but we do need a value that we're going to set. And we might say this.age equals age. And recall that this keyword allows me to separate between, I'm talking about the field that I as an animal own and the parameter that was just given to me right here. So a moment ago, I meant to say d.age equals negative 300. And it won't let me do that because that field is private. But I could now say, instead, I could say d.setAge to negative 300. And this now works. The reason it works is because the modifier, the access, on the setAge method from the animal class is public. So this is how we would set it. Now, you're probably thinking to yourself, we still have the same problem, right? This is still an invalid piece of state. Well, look what I can do here. I could say, look, if age is less than 1, then I could alert the user. I might say something like invalid age set, right? So that the user is aware, or the programmer who's trying to call setAge is aware that something failed. If that was not the case, if we got a valid age, then we can say this.age equals age. And as long as we're being thorough here, we might say if the age was less than 1, that's probably invalid. Also, if the age was greater than 30, I don't think I've ever heard of a dog whose age was greater than 30. And my mistake, logically, we don't want to say and. It would be impossible to be a number less than 1 and greater than 30. That's not right. But we would say or. If it's either of these, we would notify that it's an invalid age being set. All right, so we save here. We run our program, and it says invalid age set because we tried to set it to -300. But if I tried to set it to 17, it's a reasonable dog age, a venerable dog age. It worked, no problem. It set the age for me. All right, so in summary, what are we talking about here? When we have an encapsulated field, we need to make sure that we have provided public access to get it and change it. We need setters and getters. And the reason I'm recording this video in the inheritance unit is because even though we inherit everything from our parent, we do not inherit our parents' permission. If I inherit a private field, then I had better also inherit a public getter and setter that will allow me to change that, because just because I'm the child doesn't mean I have the same permissions, obviously. So that's the first thing we wanted to talk about in the video. The second thing we want to talk about, I'm going to go ahead and comment this out for a second, is how can we use the super keyword to access our parents' stuff. And the way to think about this is, okay, I have this eat method here. In a previous video, we demonstrated that it was overriding the eat video of my parent. Well, what if I want to access this method right here? What if I did something useful in it and I want to be able to reuse that code? Well, I can access my parent's code by saying super dot and then see what we have here. I have access to things up in the up in my parent, my superclass, so I can access. Oh gosh, let's test to see if this works. Super.name equals 13. Let's see if that works. Yeah, see, that shouldn't work because it should be type mismatch, cannot convert from an int to, oh wait, yeah. YOLO. There you go. So there's one way to get around the encapsulation issue, is you could call super to get access from your parent. It's definitely not the way you want to do it. Oh wait, I'm not dealing with age. Let's see if this works with age. That's what I was meant to do. Super.age equals 13. Okay. Whew, that's what I thought. I thought that everything was breaking there for a second. So normally, super is a keyword that allows you to access both the variables, the fields, and the methods and behaviors of your parent. But if you have encapsulated one of those fields, then you can't access it. String name was not encapsulated, so I could access it, but the age was encapsulated, so I could not access it. Which, by the way, because we inherit name, I think we're able to refer to name right here as if we have it. Let's see if that works. Bowser. Yeah, so I can say name. I can say super.name. It would do the same thing here. Really, by just calling super.name, I would be emphasizing I'm changing a field that was inherited. So that's a choice you get to make. But the real reason I had gone down this tangent was because I want to show that you can get access to a parent's methods. So if I say super.eat, now whenever a dog is asked to eat, here are the things it must do. It must say system.println slurp, and then it says, hey, how does my parent eat? Go eat like my parent. My parent says yum. And this is how dogs eat. So when I say d.eat, we should see in the console slurp and then yum. So what was the point of bringing this up? For the same reason that we call methods to allow for code reuse. Suppose you have inherited or you have overridden a method and it's useful, but you still want to get access to how it's normally done. You can call super.eat. If there were multiple methods in the animal class, which there are, I could call super. I think it'll let me access any of those public methods up there. Super.getAge, see, just like that. So super is a keyword that allows you to call the methods of your parent. Okay. Boy, I wonder if super.setAge. Yeah, that should work. Super.setAge. So you could say super.setAge 13, and that accesses your parent's set age. I guess super probably is really only relevant for methods that have been overwritten, because recall the way inheritance works. I can just call set age, right? I've inherited that. I don't need to show that I'm going to my parents' set age. It's the same one I use. The reason we want super right here in eat for super.eat is because I replaced my eat method, which says yum, with an eat method that says slurp. And so that way I make sure I go to get my parents' version of that. So in summary, when you have an inherited private field, the child does not get access to that. You have to have public setters and getters to get that done. And if you have overridden a method, but you still want access to how your parent did it, you can use the super keyword to get access to parent methods, to parent fields, although that's probably not how you want to write that. And we're also going to find out in a future video that's how you get access to parent constructors. Okay, thanks for watching.